countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Hi, good evening teachers, parents, and all wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you ready for today's lesson. Before we proceed, let's begin our section by reciting a prayer for Muslims. The non-Muslim may pray according to your own religions. Okay, let me introduce myself. I'm Teacher Kong from College Matrikulasi Perak, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So, are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Tang from College Matrikulasi Selangor. We are now live on Teacher Tang's channel. Please support her channel by clicking subscribe now. The topic of today's lesson is valence electron pair repulsion theory. And together with us, we also have Cikgu Shannon from College Matrikulasi Pulau Pinang, who is control host in charge ensure the smoothness of our lesson on technical support. And Teacher Vivi Lau from Pusat Tingkatan 6 SMK Tinggi Klang as observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson, stop chatting and use the chat section wisely. Number 2, regarding e-certificate link, the link will be given at the end of our section. Please use suitable account when you fill in your particulars and make sure to listen the passcode given by the presenter or me by the end of the lesson. And fill in the form within the time limit, which is 30 minutes. Now, Teacher Kong want to announce the passcode. Okay, so the first two passcode is A8. A8. Get it? A8. Okay, so now, okay, without further ado, let's welcome Teacher Tang.
Good afternoon, all the students, and thank you, our moderator. So good afternoon to all the students. So I'm Teacher Tan Yi from College Matrikulasi Selangor. I have 8 years experience of teaching chemistry. So this is my pre-U chemistry group. So we are all led by Cikgu Shannon. So in the group we have Teacher Vivi Lau, me, Cikgu Mawar, and also Teacher Kong. This is the pre-U mathematics group led by Teacher In, and the pre-U biology group led by Cikgu Faiza, and the pre-U physics group led by Cikgu Rosmaya, and the pre-U accounts and economics group led by Madam Fizi. So now come to our topic for today. So my topic today is a molecular shape, and then basically, what's the importance of molecular shape? Molecular shape is very important in determining the properties of a substance or a molecule. Like for example, why oxygen and carbon dioxide can be bound to hemoglobin to carry oxygens in our blood. It is because both oxygen and carbon dioxide, they have same molecular shape. Therefore, they can bind reversibly to the hemoglobin to carry oxygens or carbon dioxide in the blood. Okay, so besides oxygens and carbon dioxide, carbon monoxide can also bind to hemoglobin in the blood. Why? It is because carbon monoxide also having same molecular shape with carbon dioxide and oxygen. Because of this, carbon monoxide can also be bound to the hemoglobin in the blood, okay, and then cause carbon monoxide poisoning. Okay, so based on these situations, we can see that basically molecular shape can determine the properties of a molecule. Like for example, oxygen, carbon dioxide, and carbon monoxide, all of them having same molecular shape. Therefore, all of them could bind to the hemoglobin. Okay, so this is our topic for today, molecular shape. So molecular shape, basically, the molecular shape is basically determined by the Vsepr theory, so the valence shell electron pair repulsion theory. So based on this theory, Vsepr theory, basically it says that, so around the central atom, the electron pairs, they would want to arrange themselves as far apart as possible in order to minimize the repulsions. We know that electrons, they are all having negative charge. Okay, so around central atom, there are electron pairs, be it bonding pairs or lone pairs. So there are electron pairs around central atom. And these electron pairs, they will repel each other. And in order to minimize the repulsion, they need to arrange themselves as far apart as possible in order for the repulsions between them to be minimum. So I told you already, around the central atom, okay, so the electron pairs can either be lone pair or bonding pair. Okay, so lone pair are closer to the central atom. So they are closer to the nucleus of the central atom. Therefore, around the central atom, the lone pair repulsion will be the greatest because they are the closest to the central atom, followed by the lone pair bonding pair repulsion, and the weakest will be the bonding pair repulsion. And how do we determine the molecular shape? So basically, there are 4 steps we can follow through in order for us to determine the molecular shape of a molecule. Okay, so first, we need to draw the Lewis structure first. Then, from the Lewis structure, we can determine how many total electron pairs around the central atom. And then from the total electron pairs around central atom, we then determine the electron pair geometry. And then in step number 3, we draw and state the molecular shape for the molecule based on the electron pair geometry. And then in step number 4, we determine the type of repulsion around the central atom. And then from there, we determine the bond angle within the molecule. Okay, so we are going to look at this 4 steps again later on. Again, I'm going to guide you. No, we are going to revise how to determine the molecular shape of a molecule. So, so this is revision. So molecular shape. So if around the central atom, they are only having only having 2 bonding pairs, no lone pair. So the total electron pair around the central atom will be 2. And these 2 electron pair, the bonding pair, they need to stay as far apart as possible. So how to stay as far apart as possible to minimize the repulsion? So means that they need to be, so this is the bonding pair, so they need to stay 180 degrees apart in order to minimize the repulsion. And this will give us the electron pair geometry as linear, where the 2 bonding pair, they are staying as far apart, so which is 180 apart from one another. Okay, so if the molecule having 2 bonding pairs around central atom and total electron pair 2, so the molecular shape would therefore be linear. And what type of repulsions involved? So only bonding pair around the central atom. Therefore, the molecule, okay, is going to have two bonding pairs repel equally within the molecule, and therefore the bond angle is 180 degrees. So how about if around the central atom, there are total 3 bonding pairs, no lone pair. So if only 3 bonding pairs, no lone pair, total number of electron pair around central atom will be 3. And then how can this 3 electron pair minimize the repulsion? So again, they need to stay as far apart as possible. So how to stay as far apart as possible? So basically, we need to stay like this. So these 3 bonding pair, they stay as far apart as possible. So will give us the angle between them 120 degrees. Okay, so and then this is we look from the top. We look from the front. Okay, so if we look from the top, we can see that it is like a plane like this. Okay, so because of that, this electron pair geometry, we call it as trigonal plano. Plano because it is lying on the plane like this. It's a flat plane. Okay. So, and this 3 bond angle, so this 3 bond angle, again, they need to minimize the repulsion, stay as far apart as possible to minimize the repulsion. Therefore, they need to stay 120 degrees apart. Okay, so what type of repulsions involved? Only 3 bonding pair. Therefore, these 3 bonding pairs will repel equally to give bond angle 120 degrees. What is bond angle? So bond angle is the angle between bonding pair. So this is the bonding pair, this is the bonding pair. So the angle between the bonding pair, so this is 120 degrees. Okay, so how about now if we are having around the central atom, we are having 1 lone pair, 2 bonding pair. So if having 1 lone pair, 2 bonding pair, total still having 3 electron pair around the central atom. So the electron pair geometry is still trigonal plano. It's still like this. But then now, around the central atom, 1 is lone pair. 1 is lone pair, only 2 bonding pair. So means that one of these, it need to, so no longer bonding pair, so it need to become lone pair. It need to become lone pair. So when 1 is lone pair, 2 are bonding pair. So this molecular shape, can you see that it is like a letter V? Therefore, this molecular shape, we call it as V shape or band. Okay, so what type of repulsions involved? So now we have 1 lone pair and then 2 bonding pair. So means that the type of repulsions involved here will be lone pair, bonding pair repulsion, and also bonding pair repulsion. And lone pair, bonding pair repulsion is greater than the bonding pair repulsion. And then what will be the bond angle now? So remember, the electron pair geometry is still based on the trigonal plano. Still based on trigonal plano, so it's 120. But then now, because lone pair bonding pair repulsion is greater than the bonding pair repulsion, that causes the bond angle, the angle between the 2 bonding pair to be less than 120 degrees. Okay, because lone pair bonding pair repulsion is greater than the bonding pair repulsion. Okay, so now we move on to look at now having total 4 electron pairs around the central atom. So if around the central atom consists of 0 lone pair and 4 bonding pair, so total will have 4 electron pairs around the central atom, and the electron pair geometry for having total 4 electron pair around central atom is tetrahedral. So tetrahedral, so the 3D molecule will be something like this. So we can see that, so this is the central atom. So 1 bond out, 1 bond to the side here, and then this bond is coming towards us. So if coming towards us, we can use solid wedge to represent the bond. And then this bond is away from us. We can use dash wedge to represent the bond. And then one more thing regarding on the tetrahedral is, can you see this 3 bond? So these 3 bond, 1, 2, 3, they are pointing downwards. So when you draw, you must draw them pointing downwards. Okay, must draw them pointing downwards. So this electron pair geometry, we call it as tetrahedral. So, So if having total 0 lone pair, 4 bonding pair, so total 4 electron pair around central atom, electron pair geometry tetrahedral, and the molecular shape is also tetrahedral if 4 are bonding pair. Okay, so and then these 4 bonding pairs, they will repel equally to give the angle between the bond as 109.5 degree. Okay, so this is the bond angle between the bonding pair. Okay, but if now consists of 1 lone pair, 3 bonding pair, total electron pair is still 4 around central atom. So the electron pair geometry is still tetrahedral, but then now 1 is lone pair. 1 is lone pair. So where should we put the lone pair? So we can put the lone pair here. So when put the lone pair here, can you see that the 3 bonding pair, form a pyramid? So these 3 bonding pairs standing out like this, and then look like a pyramid, and then this pyramid having triangle as the base. Therefore, this shape, we call it as trigonal pyramidal. Okay, because the 3 bonding pairs stand out like a pyramid with triangle as the base. Okay, so in trigonal bipyramidal, because consists of 1 lone pair, 3 bonding pair, so the type of repulsions involved will be lone pair bonding pair repulsion, which is greater than the bonding pair repulsion. And the bond angle will be less than 109.5. So why 109.5? Because the total electron pair around central atom is still 4, and the electron pair geometry is still tetrahedral. So the bond angle must follow the tetrahedral. But now because of the presence of the lone pair, and the lone pair bonding pair repulsion is greater than the bonding pair repulsion, causes the bonding the angle between the bonding pair to be less than 109.5. So how about now if we have 2 lone pairs and 2 bonding pairs? So total is still 4 electron pair around central atom. So the electron pair geometry is still tetrahedral. So still tetrahedral like this. But then now 2 are lone pairs. So where should we put the lone pairs? So we can put the lone pair here and also at the back here. Okay, so to give us something like this. Okay, so this molecular shape is called V shape because the bonding pairs form like a letter V. Okay, form something like a letter V. So we call this V shape or band. Okay, so we call this molecular shape V shape or band. So what type of repulsions involved? Now we have 2 lone pair. So therefore we have lone pair repulsion, which is the greatest, followed by lone pair bonding pair repulsion. And then the bonding pair repulsion will be the weakest. And then what will be the bond angle? So angle between the bonding pair, again, it will be even less than 109.5 degree. So why 109.5? Because the electron pair geometry is still tetrahedral because total 4 electron pair around central atom. So therefore, the bond angle is still based on the tetrahedral angle. But then with the presence of the lone pair, the angle therefore is less than 109.5 degree. So that's it for the 4 electron pair around central atom. Now we move on to look at if total having 5 electron pair around central atom. So what would be the molecular shape? So if all the electron pairs are bonding all the 5 electron pairs are the bonding pair. So total still having 5 electron pairs around central atom, and the electron pair geometry is trigonal bipyramidal. Okay, so the 3D electron pair geometry is something like this. So this is the central atom. So we have one bonding pair up, one bonding pair down. So these two form the axial plane. So the one up and down forming the axial plane. Okay, and then 3 lying on the equatorial plane. Okay, so these 3 lying on the equatorial plane. Okay, so this bond is like this, and this bond coming towards us. So if coming towards us, again, use solid wedge to represent it. And then this bond is away from us, so we use dash wedge to represent it. And then why we call this trigonal bipyramidal, it is because these 3 triangle, these 3 bond, okay, these 3 bond on the equatorial plane form a triangle. If we join the terminal atom, can you see it form a triangle? And then if we join the terminal atom to the axial, the atom at the axial, can you see that it form a pyramid? And then if we join to the atom at the bottom one, also form a pyramid. So can you see that we have 2 pyramids, one up, one down, with the base triangle. Therefore, we call this as trigonal. So trigonal because the base of the pyramid is triangle. So bipyramidal, bi means 2 pyramid. So bipyramidal. Okay, so this electron pair geometry, we call it as trigonal bipyramidal because forming 2 pyramid, one up, one down with triangle as a base. So if having total 5 bonding pair, the molecular shape will be trigonal bipyramidal, and these 5 bonding pairs, they will repel equally, so to give bond angle. So if we look at the 3D structure, so what is the bond angle when the electrons staying as far apart as possible from one another? So axial to equatorial is 90 degrees. Within the equatorial, the bonding pair are 120 degrees apart from one another. Therefore, give 2 bond angles 90 degree and also 120 degree. Okay, so again, 90 axial to equatorial, 120 between the bonding pairs between the equatorial plane. Okay, so in the equatorial plane. Okay, so how about if now we have 1 lone pair, 4 bonding pair? So 1 lone pair, 4 bonding pair, total still having 5 electron pairs around central atom. So electron pair geometry is still trigonal bipyramidal, but then now having 1 lone pair, where should be the lone pair? So again, want to minimize the repulsion. So if want to minimize the repulsion, the lone pair should go to the place where the angle is the biggest. So just now we already know that the angle is the biggest at the equatorial plane, Therefore, the lone pair should go here. Okay, so should go here. Actually, one of the bond on the equatorial plane and give us the molecular shape seesaw. Okay, so now because one is lone pair, therefore we have lone pair bonding pair repulsion, which is greater than the bonding pair repulsion. And what are the bond angles? So axial to equatorial now to be less than 90 degrees. Okay, because lone pair bonding pair repulsion is greater. And on the equatorial plane, these 2 bonding pair now will have less than 120 degree angle apart from one another. Okay, because lone pair bonding pair repulsion is greater than the bonding pair repulsion. So we move on to look at if we are having 2 lone pair, 3 bonding pair, total still 5 electron pair around central atom. So the electron pair geometry is still based on the trigonal bipyramidal, but now we have 2 lone pair. So where should the lone pair goes? Again, it need to go to the equatorial plane because the angle larger, so repulsions will be less. So it should go to the equatorial plane. So here will be the lone pair. So and then the remaining bonding pair form a letter T. Can you see? Form a letter T. Therefore, this molecular shape is called T shape. Okay, and now we have 2 lone pair. Therefore, we have lone pair repulsion, which is greater than the lone pair bonding pair repulsion, and then which is greater than the bonding pair repulsion. So now we only have axial to the equatorial. So therefore, the bond angle is less than 90 degrees. Okay, so if we have 3 lone pairs, 2 bonding pairs around central atom, total still 5 electron pair around central atom. So the electron pair geometry is still based on the trigonal bipyramidal. Okay, and where should be the lone pair goes? Again, need to go to the equatorial plane because larger angle can minimize the repulsion. Okay, and this will give us a molecular shape, linear shape. Okay, so this one is a linear shape. The bonding pair form linear shape. So here we have lone pair, 3 lone pairs. So we have lone pair repulsion, and we also have lone pair, bonding pair repulsion, and also bonding pair repulsion. Okay, and this lone pair, they are at the equatorial plane, so it will exert equal repulsions up and down. Therefore, give us bond angle. So bond angle is angle between the bonding pair. So exert equal repulsions up and down, therefore giving us bond angle 180 degrees, okay, between the bonding pairs. So we move on to look at the last class, okay, so the octahedral. So if we have 0 lone pair, 6 bonding pair, total 6 electron pairs around central atom. So the electron pair geometry will be octahedral. So octahedral is something like this. So this is the central atom, and then 1 bond out, 1 bond down, and then this 2 bond is towards us. So towards us, we use solid wedge. And then these 2 bonds are away from us. So we use dash wedge. And in order to minimize the repulsion, all these 6 bonding pairs, they need to stay as far apart as possible to minimize the repulsion. And that gives us, can you see that? The bond angle, the angle between the bonding pair, 90 degrees. Okay, so 90 degrees. Okay, so if all are 6 are bonding pair, so again, this 6 bonding pair will repel equally to give bond angle 90 degrees, and the molecular shape is octahedral. So if 1 is lone pair, another 5 are bonding pairs, still total 6 electron pairs around central atom. So the electron pair geometry is still octahedral, okay? But then now 1 is lone pair. So where should be the lone pair goes? So basically the lone pair can go to anywhere, but the easiest to draw is to draw up or down. So here I draw down. So here is the lone pair. So when lone pair is here, can you see that the remaining bonding pair, so if I join the terminal atom, so can you see that this is like a square, and then if joined to the terminal atom on the top, so it forms a pyramid with a square base. Therefore, this molecular shape, we call it as square pyramidal. So the square is the base, and then stand out like a pyramid. Therefore, the molecular shape is called square pyramidal. So in a molecular shape square pyramidal, we have one lone pair and then 5 bonding pair. So therefore, we have lone pair bonding pair repulsion, which is greater than the bonding pair repulsion. And since the lone pair bonding pair repulsion is greater, therefore now the bond angle is less than 90 degrees. So why 90? Because the electron pair geometry is octahedral, so it's still based on the bond angle of the octahedral. Okay, but then due to the lone pair bonding pair repulsion being greater than the bonding pair repulsion, so the bond angle now is less than 90 degrees. So how about if we have 2 lone pairs and then 4 bonding pairs, total still having 6 electron pair around central atom. So we are still having electron pair geometry octahedral. And where should we put these 2 lone pair? So just now I put one down. So another one to minimize the repulsion. So another one need to be the opposite side. Okay, need to be the opposite side. So just now down. So another one need to be on the top. Okay, so this gives us square planar molecular shape square planar because these 4 bonding pair form a square, and then it is a plane, a flat, is lying flat. So in a plane, so therefore it's called square planar, this molecular shape. Okay, so and then so in here we have 2 lone pair. So we have lone pair repulsion, which is greater than the lone pair bonding pair repulsion, and which is greater than the bonding pair repulsion. And now the bond angle is 90. So why 90? Based on the octahedral 90. But why not less than 90? It is because one lone pair is up, one is down. So they exert equal repulsion from the top and from the bottom. Okay, therefore these 4 bonding pair, they are lying flat to give a square shape lying on the plane. Okay, so since it is flat, means that the angle between the bonding pair is 90 degrees. So this is a revision for the electron pair geometry and also the molecular shape. So now, shall we move on to look at question 1? So we look
Hi,
at
Teacher Tang.
yeah.
Okay, let's stop for a while for advertisement.
Oh, okay, sure.
Thank you.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay.
Let's continue our lesson with Teacher Tang.
Okay. So now we move on to look at question number 1. So this is to revise what I covered just now. So if there are total 2 electron pair around central atom, so can you tell me what is the electron pair geometry? So electron pair geometry, so some would they use electron pair arrangement. So some they use a basic molecular shape. Some even use electron domain arrangement. Okay, but they all refer to the same thing. Okay, so if total there are 2 electron pair around central atom, so can you tell me what is the electron pair geometry for that particular molecule? Okay, I give 10 seconds. Any answer from the students?
Not yet, but getting from Aina. Hi, madam. Hi, Aina. Okay.
Yeah.
Let's try the exercise.
So if total 2 electron pair around central atom, can you tell me what's the electron pair geometry for the molecule? Okay, so it's linear.
Answer from Justine.
Yeah? Oh, linear.
Linear.
Okay, good. So if total 3 electron pair around central atom, so what would be the electron pair geometry of the molecule? Yeah, so I give you 10 seconds as well. So 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay.
Answer from Fitri, Aina, trigonal planar.
Okay, very good. Trigonal planar. So you do need to know what is the molecular pair geometry in order for you to draw the molecular shape. Okay. So how about if total 4 electron pair around central atom? Can you tell me what's the electron pair geometry for the molecule? So 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1.
Answer from Aina, tetrahedral.
Okay, very good. Tetrahedral. So how about having 5 electron pair around central atom? So what is the electron pair geometry for the molecule? So 10 seconds. Any answer from the student? 5, 4, 3, 2, 1.
Okay, from Fitri, trigonal bipyramidal.
Okay, trigonal bipyramidal. Okay, good. So how about if total around central atom, total having 6 electrons around the central atom, then what would be the electron pair geometry for the molecule? So 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, from Justine, Chai, and Fitri, octahedral.
Okay, octahedral.
Zain
good.
also give the answer octahedral.
Okay, very good. Okay, so it is very important for us to know electron pair geometry for us to draw the molecular shape. Okay, so basically this is step number 2 in order to draw the molecular shape. Okay, so shall we move on to look at? So just now I already told you there are 4 steps to follow through in order to determine the molecular shape of a molecule. Okay, so first we need to draw the Lewis structure, and then in step number 2 we need to count how many electron pairs around the central atom, and then from there we determine the electron pair geometry. So it's this. Okay, so this is step number 2. We count the total electron pair around central atom, then we determine the electron pair geometry. So this is step number 2 in determining the molecular shape of a compound. And then step number 3, we need to draw the molecular shape based on the electron pair geometry that we deduce in step number 2. Okay, and then from the molecular shape, we determine the type of repulsions involved and also state the bond angle. So let me give you example. So this is example 1. So again, to determine the molecular shape, ignore the question number 3. Okay, so okay, how to determine the molecular shape of a compound? So 4 steps to follow through. So step number 1, we need to draw the Lewis structure. So what are the atoms involved? Carbon and chlorine. So to draw the Lewis structure, we count the total number of valence electrons involved, and then we draw the skeletal structure. So carbon less electronegative than chlorine, so it becomes the central atom. So we draw the skeletal structure. So I already drawn 8 electrons, so 24 electrons left. So remember, we need to make the terminal atoms octet. So put in another 6 electrons on each of the terminal atoms. So I have drawn 24 electrons, so no more electron left for the central atom. So this is step number 1. We draw the Lewis structure for the molecule. And then in step number 2, we want to determine the electron pair geometry. So how to determine the electron pair geometry? We need to first count how many electron pair around the central atom. So like in this molecule, around central atom, carbon, there is no lone pair, but there are 4 bonding pair. So total electron pair around central atom is 4. So you already, just now we already revised. So if having 4 electron pair around central atom, that means that the electron pair geometry is tetrahedral. So means that, so this is tetrahedral. So this is step number 2. Okay, we determine the total electron pair around central atom, and we determine the electron pair geometry. And this electron pair geometry is very important because it will become the backbone for us to draw the molecular shape. So step number 3, only we draw the molecular shape. So step number 3 is based on step number 2, the electron pair geometry tetrahedral. It's based on electron pair geometry. So we already determined in step number 2, the electron pair geometry is tetrahedral. So in step number 3, we want to draw the molecular shape. It needs to base on this electron pair geometry. So how to draw? So we need to draw based on electron pair geometry. So this is the molecular shape. And this molecular shape, we can call it as tetrahedral. So based on the molecular shape, we can see that all these 4 are bonding pairs. So means that in step number 4, okay, we can, what type of repulsions involved? We know that 4 are bonding pairs. So these 4 bonding pairs will repel equally. So repel equally, and for the tetrahedral, so repel equally, therefore the bond angle will be 109.5 degrees. Okay, so now we move on to look at example 2. So for example 2, okay, so ignore the question number 3. So for example 2, it's still the same. How do we determine the molecular shape of IF3? So it's still the same. Step number 1, okay, we draw the Lewis structure for IF3. Okay, so to draw the Lewis structure, first we need to calculate the total number of valence electrons involved. So which is this? And then we draw the skeletal structure. So I have drawn 6 electrons. Okay, and then measure the terminal atoms octet. So for each of the terminal atom, put another 6 electrons. So octet. So, and then 4 more electrons left, and these 4 electrons left need to go to the central atom. So this is step number 1, Lewis structure. Draw the Lewis structure for IF2. Then in step number 2, we need to determine the electron pair geometry. So from the Lewis structure, we can see that around the central atom iodine, there are 2 lone pair, 3 bonding pair. So 2 lone pair, 3 bonding pair, therefore total 5 electron pair around central atom. So total 5 electron pairs around central atom means that the electron pair geometry is trigonal bipyramidal. So it's something like this. So in step number 3, when we want to draw the molecular shape, you need to base on step number 2, the trigonal bipyramidal electron pair geometry. So how to draw them? So two are lone pair. So lone pair need to go to the equatorial plane for the trigonal bipyramidal in order to minimize the repulsion. So that will give us something like this. And this molecular shape, can you see, is a letter T. So therefore, this molecular shape is called T shape. Okay. So from the molecular shape, we can see that. So what type of repulsions involved? Now we have two lone pair. So it means that we have lone pair repulsion, and lone pair bonding pair repulsion, and also bonding pair repulsion. Okay. So and therefore the bond angle. So the bond angle, okay, now will be less than 90 degrees. Okay, because lone pair repulsion is greater than the lone pair bonding pair repulsion, and which is greater than the bonding pair repulsion. So to cause the T shape to have the bond angle less than 90 degrees. So we move on to look at example 3. So how to determine the, again, ignore the question number 3. So how to determine the molecular shape of SEF5 plus ion. So again, first we need to draw the Lewis structure. So for this one, we need to calculate all the valence electron, but here positive 1, so need to minus 1 to give us total 42 electrons involved. Okay, and then what we need to do is, okay, we draw the skeletal structure. So xenon is the central atom, okay, less electron negative. So fluorine terminal atom. So this is ion, so need to have the charge. Okay, so I have drawn 10 electrons that involved in the bonding pair. So 32 electrons remain. So, and then we need to measure the terminal atoms octet. So by putting 6 electrons in each of the terminal atoms. So by doing so, I have drawn 30 electrons. So 2 more remains. Okay, so these 2 remain, we'll put at the central atom. Okay, so this is the Lewis structure for XeF5 positive ion. Okay, so this is step number 1, draw the Lewis structure. Step number 2, we need to determine the electron pair geometry for this ion. So around central atom, xenon, we can see that there is 1 lone pair. So this is the lone pair. So, and 1, 2, 3, 4, 5 bonding pair to give total electron pair around central atom xenon equal to 6. So total electron pair around central atom 6, so means that this electron pair geometry is octahedral. So octahedral, so it will be something like this. 2 towards you, 2 to the back. Okay, so something like this, the octahedral. So this is step number 2. Okay, so we determine the electron pair geometry for the molecule, and then the molecular shape we need to draw it based on the electron pair geometry. Step number 2. So how to draw it based on the electron pair geometry? Octahedral. So the lone pair in octahedral, it can go to the top or bottom. Remember, it can go to the top or bottom. Okay, so let me draw. So this is the central atom. So I draw the lone pair first. So go to the bottom. Okay, so and another 5 bond. So lone pair go here. So another 5 bond will be, so one top, another 2 towards you, another 2 away from you. Okay, and this is ion. And this molecular shape, so this molecular shape, can you see this is, the base is square and then stand up like a pyramid. So the molecular shape is called square pyramidal. And then what? Okay, step number 4, we need to determine the type of repulsion. So we have 1 lone pair and then 5 bonding pair. So the type of repulsions will be lone pair, bonding pair repulsion. And it is greater than the bonding pair repulsion. And what is the bond angle? So bond angle must based on the octahedral. We know that in octahedral is 90 degrees, but now in a square pyramidal, one is a lone pair, therefore the bond angle will be less than 90 degrees. Okay? Okay, so this is example 3. So now move on to question number 2. Okay, so what is the molecular geometry of Nf3? So I give you 2 minutes. Okay, I give you 2 minutes. So I let you try. What is the molecular geometry of Nf3? So I already taught you. I already revised with you how to do this. Okay, follow through the 4 steps. So step number 1, you draw the Lewis structure first. And then you determine the total electron pair around central atom and the electron pair geometry. That is step number 2. And then in step number 3, you draw the molecular shape based on the electron pair geometry that you deduce in step number 2. Okay? So I give you 2 minutes to do this question. Maybe 1 minute, 1 minute. Okay. So I give you 1 minute to determine what is the molecular geometry of Nf3. So molecular geometry is basically refer to molecular shape. It's just another name of it. Okay. So what is the molecular geometry of Nf3? So I told you already, follow through the 4 steps. This one, they do not ask you to determine bond angle, so you can skip step number 4. So you just do up to step number 3. So what is the molecular shape? Molecular shape, not electron pair geometry, molecular shape, not electron pair geometry, is molecular shape or molecular geometry. So any question from the students?
Hi, Teacher Tang. There is one answer, okay, from Hazid. B. He got
B?
tetrahedral.
Okay, shall we look at the answer? The answer is C, trigonal pyramidal. So why? Shall we look at the explanation? So do you get the Lewis structure correct? So this is step number 1. Okay, you draw the Lewis structure. So this is the Lewis structure of Nf3. So in step number 2, we need to determine the total electron pair around the central atom. So lone pair around central atom nitrogen, lone pair is 1. Bonding pair 1, 2, 3. So 3. So total electron pair around central atom therefore is 4. And this electron pair geometry is tetrahedral. Okay? But electron pair geometry is not molecular geometry. Molecular geometry refers to molecular shape. So instead number 3, we want to draw the molecular shape. It need to base on the tetrahedral. It need to base on this tetrahedral. But then now we have one lone pair. So where should we put the lone pair? We can put it here. So means that here. But then these three bonding pair, it need to like the bonding pair in the tetrahedral. So means that they need to be like this, and like this. So can you see that this molecular shape? So these three terminal atoms, we join them together, it will form like a triangle, and they stand out like a pyramid. So the molecular shape is called trigonal pyramidal. So therefore the answer is C. Okay, it's all right, it's a good try. You can try question number 3. Hopefully you get it correct. So how about CO3 2-? What is the molecular geometry? So molecular geometry is molecular shape. Of CO3 2-. Okay, again, I give you 1 minute to try. Okay, so question number 3. Okay, any answer from the students? Teacher Kong?
Fitri Zafandi, answer A.
A, okay. Oh yeah, that's correct. Okay, so the answer is A. Okay, so again, 4 steps. So this is step number 1, the Lewis structure for CO3 2-. So step number 2, we want to determine the electron pair geometry. So first we need to calculate the electron pair first. So around the central atom, any lone pair. So around central atom carbon, no lone pair. Bonding pair. So multiple bond, consider 1. Okay, consider 1. So therefore it's 1, 2, 3. Total 3 bonding pair around the central atom. So therefore total 3 electron pair around central atom, and the electron pair geometry is trigonal planar. Okay, so something like this. And step number 3, we want to draw the molecular shape. It need to base on the trigonal planar. So means that I need to draw something like this. It need to base on this. Okay, so this is the molecular shape for CO3 2-, and it is trigonal planar. Very good. Okay, so that is question number 3. So question number 4. Okay, 1 minute. Okay, maybe I give you the Lewis structure. Okay, so this is the Lewis structure. So step 2. So around central atom xenon, lone pair is 1. Bonding pair. So multiple bond consider as 1. So 1, 2, 3, 4. 4. So total electron pair around central atom is 5. So the electron pair geometry is therefore trigonal Bipyramidal. Something like this. And step number 3, we need to draw the molecular shape based on the trigonal bipyramidal. So where should be the lone pair? The lone pair need to go to the equatorial plane. Okay, need to go to the equatorial plane. Okay, to minimize the repulsion. So we should. So let me draw. So here the lone pair. Okay, so fluorine. So we should get something like this. So this molecular shape, we call it as seesaw. So it's just like the seesaw you play with your friends at the playground. So one seat here, one seat another side. Okay, so this is a seesaw molecular shape. Okay, so Teacher Kong, is it the time?
Yeah, it's time up.
Oh.
Time's up.
Okay, so I think question number 5, we can do it on your own. The answer is B. Okay, you can screenshot and then try these questions on your own. Okay, so that's it from me today. Thank you, everyone. So back to the moderator. Yeah.
Yeah, we've got Grace. We are done with today's section. We have learned a lot from Teacher Tang about molecular geometry. Congratulations to those who are able to follow our section from the beginning till the end. And thank you very much, Teacher Tang, for such an interesting lesson. Okay, now I will announce another 3 passcode, which is 308. 308. 308. Okay, so now I would provide the certificate link, and please check the chat box for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Teacher Tang for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new video and live classes from Teacher Tang. If you like today's lesson, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? When you have finished, type done in the chat section. Then, okay, once again, I would like to thank you, Teacher Tang, for the interesting lesson. Thank you also, Teacher Vivi Lau and Sir Shannon, for being with us today. I think that's all for now. See you in another section. Goodbye, everyone. See you on next week. Bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.